welcome to the next segment of our lecture series. We are now on lesson 5.2, solving absolute value inequalities. And our objective again is to define what an absolute value inequality is and how do we solve absolute value inequalities. So let's start with the definition. Definition of absolute value inequality. It is an inequality that has a variable expression enclosed in an absolute value sign or symbol. Okay, like how we define our absolute value equation, we can have here ax plus b, absolute value, not equal to c, where a, b, c element real, a not equal to 0 is an absolute inequality in x. Okay, so we have a variable x here inside. Okay, how do we solve this type of inequality? Okay, first we can illustrate by using solving an absolute value inequality by using these theorems. Okay, solution by this theorem. Theorem 1, absolute value of triangle less than k for k greater or equal to 0 implies that triangle is between k and negative k. If this one is less than or equal to k, then this will be less than or equal to less than or equal to. Okay? Now, the other theorem, absolute value of triangle greater than k for k greater or equal to 0 implies triangle greater than k or triangle less than negative k. If you will notice, this one looks like our solution for a quadratic inequality. Let's say this quadratic inequality, ax squared plus bx less than c, plus c less than 0, where a is positive. This one, the solution is towards each other. And this one here, the solution of the inequality ax squared plus bx plus c greater than 0 for a positive, the solution is going the opposite direction. So these are related here. Okay, now, so if we use this theorem to solve an inequality, there are again trivial cases. For example, absolute value of x minus 5 less than negative 3, for example. If this is a negative number, then this theorem cannot be used. I already know that this absolute value on the left hand side can never be less than a negative number. So I can already say that my solution there is null set, or I cannot find any x such that the absolute value of x minus 5 is less than negative number. If we take the opposite, let's say this one here, absolute value of x minus 5 is always greater than a negative number because the absolute value of a number is non-negative. So for any x that you can think of, this expression on the left is always greater than that negative number. So this is an absolute inequality. Therefore, the solution set is R. And this is a contradiction. There's a null set solution. Now, these are trivial cases. We will now have cases where k is greater or equal to 0. Okay. So, for example, I will have here absolute value of x minus 5 less than 0. Will this happen? Will this ever be less than 0? No. So your solution to this is null set. However, if I have, okay, the solution to this is null set. What about if I have this one less than or equal to 0? So I allow this one to be 0. So what will make this 0? It will be 5. So there is one number that will satisfy that inequality. And that number is 5. 5 minus 5 is 0. Any other number than 5 will make this one greater than 0 already. This expression. Okay? So, what about this? The opposite. Will this one be always true? Will this always be positive? No. It will not be positive when x equals 5 because this becomes 0. So therefore, your solution here will be all r except what? That which makes this 0 except 5. However, if you have here x, absolute value of x minus 5, absolute value of x minus 5 greater or equal to 0, then you allow this to be 0 or positive. So the solution will be all r. Okay, now let's see those that are not trivial. Okay, where these are not negative or 0. So we have something like example here will be, let's say, x minus 5 less than 3, for example. Absolute value x minus 5 less than 3. Now, this theorem can work. Okay, instead of having less than 3, I will just say less than or equal to 3. So 3 is positive, and this absolute value now can be written, and I will say negative 3 and then x minus 5 less than or equal to 3. How will I solve for x? I'll just isolate x here. I'll add 5 to all regions there, and I will get here 2 less than or equal to x less than or equal to 8. So your solution will be closed interval from 2 to 8. Any number from 2 to 8 will satisfy this. For example, x equals 2. 2 minus 5 is negative 3. Absolute value of negative 3 is 3. So 3 is less than or equal to 3. So, what about 8? 8 minus 5 is 3. So, okay rin. Between 2 and 8, any number between 2 and 8 will satisfy this as well. Okay? So, let's have the other number. Suppose we get this one here. I will make it a strict inequality this time. Then, I will use this theorem. Okay? This theorem will be used. And I can rewrite this as what? X minus 5 greater than 3 or x minus 5 less than negative 3. And solving for the solution set, I should get x greater than 8 or x less than 2. Or I can write it in interval form, starting from here, from negative infinity up to 2, union from 8 to positive infinity. So that's my solution set. In other words, I can get any number in this interval, in that interval, and this will be satisfied. Let's say when x is 0, here in this interval, 0 minus 5 is negative 5, absolute value of negative 5 is 5, this is greater than 3, etc. You can have that. Okay, that is using the theorem. Now, suppose we will use definition again. Okay, solution by using a definition. Okay, let's say using definition of absolute value. So instead of solving for an equality 3, let's say less than. So that will be an absolute value inequality. Now, to use definition, we will now again define what this is. Absolute value of negative x minus 5 will be itself if what? Itself is greater or equal to 0. By now you should be familiar with this. And negative of itself if x minus 5 is less than 0. So, what will move here will be this, not this one. Okay? So my case 1 here will be, suppose I will have x minus 5 greater than or equal to 0. Then, if I remove the absolute value is itself. And then that's less than 3. And then, or case 2, suppose x minus 5 is negative. Then, how will this behave if this is negative? I will have the negative of itself. Okay? Again, I'm emphasizing, this one is not changed. This one is not changed. So this quantity is the one that is rewritten. Okay? Now, solving for x there, we get what? X greater or equal to 5 intersection x less than, what is this? 8. So, if I have this my critical number greater or equal to 5 going to the right and less than 8 is going to the left, my solution set here is the intersection. So, closed at 5 and open at 8. Okay, let's see what happens here. X minus 5 less than 0 gives me x less than 5. Or, I can have this negative x plus 5 less than 3. Or, negative x less than 5 transfers to the right, so it becomes negative 5. Negative 5 and 3 is negative 2. Now, I'm solving for x. I'll multiply everything by negative. And this is a negative, so I will change the direction here. I will get here what? X greater than 2. So, is there an intersection between these? This is critical number 5 going to the left. Critical number 2 going to the right. So, my intersection here is open at 2 and closed at, and open at 5. So therefore, my solution set will be the union of 5, 8, close, open, union 2 and 5. If you look at this interval, unite with that interval, it's actually saying you will start from 2, 5 is already included here, and then you will end at 8. So this is your solution set. Okay? That's how we use the definition of absolute value to solve an inequality. Okay, the last example I would like to show you is, I will change this to what? Greater than. Okay, so this is greater than. Now, there's no change except this one here. This one is greater than. Okay, and here in this case here, this is also greater than. Then, we solve. What happens? Okay, so what did I do actually here? I assume that this is positive or 0, so its absolute value is itself, greater than 3. Here, I assume that this is negative, so its absolute value is the negative of itself, greater than 3. Okay, that's how we do it. Okay, now, I will solve this. This will give me x greater or equal to 5, intersection x greater than 8. So, both of these are going to the right, and 8 is going to the right, and the intersection starts from 8. So, from 8 up to positive infinity. What about this one? X less than 5, intersection, negative x plus 5 greater than 3. Or, solving for x here, we get negative x greater than negative 2, or multiply by negative again will give me x. Then change the direction, that will be x less than 2. So, intersection x less than 5. If you're going to have the critical number 2 there and 5 there, both of these are moving to the left. So, here and here, they will intersect starting at 2. Therefore, my solution for the second inequality will be negative infinity. Negative infinity up to 2. Okay, so your solution now will be case 1 union case 2. Or case 1 here is 8 here up to positive infinity union negative infinity to 2. Okay? So, we are done with quadratic inequality. See you in the next video.